So quadratics are usually in the form ax squared plus bx plus c, where we have a, b, and c as constants or as just numbers, right? And for example, it can be like 9x squared plus 72x minus 3, or maybe just x squared, or 1 minus x squared, right? So these are just examples of quadratic expressions, right? But now if they have equal signs, right? Let's say this is equal to something, or x squared is equal to something, they become quadratic equations. And I'm sure most of us know that, right? And so we also need to understand that quadratics are always parabolas, right? And by that I mean, if we were to sketch a quadratic graph, it will look something like this or this, right? And for it to be like this, the coefficient of x squared, yeah, our a, needs to be positive, right? So for this shape, we need the coefficient of x squared needs to be positive for us to get this kind of shape, right? And obviously for this one, the coefficient of x squared should be negative, right? So if we're having a quadratic expression with a negative coefficient of x squared, for example, minus 4x squared plus 3x minus 2, or we can write it as 3x minus 4x squared minus 2, right? This will give us a shape like this, right? But keeping in mind that the graphs are always parabolas. Let me write that down. Quadratic graphs are always right. And now, if we look at these two, we can see that they are turning points, right? They are turning points on these graphs. So under this topic, we will be asked to get the coordinates of the turning points at some point in terms of x and y, right? And for this, we would need to chip in the concept of completing the square, right? Where we get something like x plus a squared plus b as a result, and then we take minus a and b to be the coordinates of the turning point, right? But before we get to this, let me give you 2 or 3 examples on how we can go about completing the square, right? So for first example, let's use x squared minus 6x plus 4, right? So when you're completing the square, I first need to check the coefficient of x squared and make sure that it's a 1, right? And now that we know it's a 1 for this particular example, we go ahead. So we write x minus half of this. So it's like this divided by 2. so that would be 3. Then we put that in brackets, then we put a square, right? Then we say plus 4, then we subtract, right, this number squared, so that would be minus 3 squared, so that will give us 9. So our final answer here will be x minus 3 squared minus 5, right? And to get the turning point of this quadratic graph, we will then say is the turning point is 3 minus 5, right? Let's do another one. So for second example, let's use x squared plus 8x plus 4, like this, right? Looking at this, we can see that the coefficient of x squared is 1 already, so we can go ahead and write x plus, then half of this, that's 4. I put a plus here because there's a plus here, right? So that would be x plus 4 in brackets, then we squared plus this 4, then we subtract this squared, right? So we subtract 4 squared, so this will be x plus 4 squared plus 4 minus 16, and this will give us x plus 4 squared minus 12, right? And from this we can certainly get our turning point. So the coordinate of the turning point will be minus this, which is minus 4, minus 4, then minus 12, right? Let's do 2 more examples with a different number as the coefficient of x squared. Let's do one with 2x squared minus 8x plus 9, for example, right? So remember what we were doing for the previous 2 examples. We were first making sure that the coefficient of x squared was 1. So it's the exact same thing that we're going to do with this one, right? And to make the coefficient of x squared 1, we're not going to divide everything by 2, but rather we're going to factor out 2, right? So we don't divide by the number that's next to x squared or the coefficient of x squared, but we factor it out, right? So factoring 2 out here, we get 2, then we put square brackets, right? So this will be x squared minus 4x plus 9 over 2, like so, right? And this will come down as 2, let me just rewrite this, x squared minus 4x plus 9 over 2. I said that we have the coefficient of x squared as 1, so we can complete the square for this expression first, then we multiply everything by these 2. So completing the square for this, we get x minus half of this, that's 2, right? And I put a minus here because there's a minus here, right? Please don't be confused. Then we put a square there, plus our 9 over 2 minus this squared, so minus 2 squared, that's our 4, right? So this is in brackets and we have a 2 outside the bracket, like that, right? And so multiplying everything by this 2, we will have 2x minus 2 squared plus 9 minus 8, right? Because we're saying 2 multiplying this, we get this, and these 2 multiplying this just crosses out with that, we get 9, and 2 multiplying this, we get 8, and this will give us 2x minus 2 squared plus 1 is our answer. And with this, we can still get the turning point using the same method that we're using for the other examples. So it will be minus this, which is in this case minus 2, then 1 here. So this will be 2, 1 is our coordinates of the turning point, right? I hope I've made that clear enough for you guys, right? So now that we know how to complete the square and get the turning point of a quadratic expression, or a curve rather, we can go ahead and make general sketches of these graphs, right? For example, these ones that we've just been using. So if we're asked to sketch this, for example, we'll just put our y-axis and our x-axis like this, right? Then we put our 3 minus 5, so that's 3 and minus 5 here, right? Then we put a point like that. Then we look at the coefficient of x squared. Yeah, we can see that it's positive, so this will be looking like this, right? So it's facing up. So then we just come here and we draw it like this, right? So this is how the general sketch will be looking like. And even for the second one, x squared plus 8x plus 4. If we look at the turning point minus 4 minus 12, the general sketch will be this minus 4 and minus 12. It will be here, right? Then we look at the coefficient of x squared. It's positive again, so it's facing up, right? So it'll be like this, right? Then we write the equation. So this will be y equals that. So we just write y equals x squared plus 8x plus 4. So whenever you make a sketch, please don't forget to write the name of the equation, right? Just y equals that. So you also do the same even when the coefficient of x squared is negative, but just keeping in mind that it will be facing down like this with the turning point up here like that, right? So you can also do the same with even this one, but I will leave that for you. So moving on from this, after you get your turning point from completing the square and sketching your quadratic graphs, you can also get the equation of the line of symmetry of your graph, right? Let's use the same examples. So let's say you have this last example as the quadratic expression in your equation. Then they say find the equation of the line of symmetry, right? You first complete the square, then you get your expression to be this, then you go on and get the turning point, which in this case is 2 and 1, like that. And you can get the equation of the line of symmetry right away from this. So this will be x is equal to 2. But let me show you how we get to that. So if we were to sketch this, like I said earlier, put your y, your x, and maybe your o, then you see that the coefficient of x squared for this particular expression is positive, so it's facing up. So your 2 and your 1, you put a point, you know your graph is facing up like this, right? This is the general look of the graph. Then you write y is equal to 2x squared minus 8x, 2x squared minus 8x plus 9. Mind you, the reason why I'm calling this a general sketch is because this graph might not be touching the y-axis for a given range, but if you're asked to make a general sketch, you can sketch it like this. The important points are this one, and if the question is 2 or more marks, this one as well. But if it's 1 mark, please just put the turning point and the general shape, right? And now from here, we know a line of symmetry will be that line that divides our graph into two, right? Into two similar parts, right? So if we're looking at this, we can see that the line x equals to 2 divides this graph into two, which is this part and this part, and the two parts are similar, right? So that's why we said the equation of the line of symmetry in this case is x equals 2, right? So it is the same case for even these other examples and the many equations that you're going to get in your exam. If they say the equation of the line of symmetry, just get your turning point and you get your x coordinate, and you write it as x equals 2, x equals minus 3, x equals minus 4, or anything like that, and that will be your line of symmetry. You get it from your turning point, right? And from here, we also need to talk about inequalities involving quadratics. And for that, we're going to start with a very simple example. X minus 4 being greater than, let me just correct that, being greater than or equal to 4 minus 2x, right? But before we go ahead and solve this, let's talk about inequalities in general, right? We know inequalities in mathematics include these signs: greater than, less than, greater than or equal to, less than or equal to, and this one, like this, right? So if we have, for example, 2x is equal to maybe 4 like this, we call this an equation, right? It's a linear equation. But if we replace this equal sign with any of these, which is not this one obviously, and this one, with any of these, and that makes it an inequality, right? But we still treat it the same as we would if we were working through it with an equal sign, like that, right? So we're going to be working through this as if it had an equal sign, but right towards the end, that's where we need to be careful, because it's an inequality and this is not just an equal sign, right? So when faced with a question like this, we just go ahead and group like terms, right? If you haven't done that already. So we take the minus 2x to the other side, so it will be x plus 2x, and that will be 3x, right? Then the minus 4 to the other side, so it will be 3x, like this. Then 4 plus that 4. So we're taking this minus 2x to this side, and this minus 4 to the other side. And we know that whenever something changes side, the sign also changes, right? In equations, right? So minus 2x will be 2x on the other side, and minus 4 will be 4. So this will be 4 plus the other 4, and that will be 8. Now from this, remember, if you have 2x equals 4, to get x, you just divide both sides by 2, and you get your x equals 2. So we're going to do the same with this, right? So we're going to work through it as if we're looking for x. So we divide by 3 both sides, so that will be 3x. Let me just rewrite this. Then we divide both sides by 3, right? So x will be greater than or equal to 8 over 3, right? And that will be our answer, right? And we might also be asked to show this on a number line, right? And for that, we just draw part of the number line. So this will be 0. You know, this is the x, and this is 2 and 2/3, right? So 2 and 2/3, right? And because it is greater than or equal to sign, we put a circle right above this number and we shade it. So we always shade for greater than or equal to and less than or equal to, right? And we leave this circle blank for greater than and less than, right? So for this particular one, we shade, right? And after shading, we ask ourselves, which of these sides, this one or this one, do we have x values being greater than or equal to 2 and 2/3, right? So that will be this side, right? So we just put this R right here, and we're done, right? Now if they go on to say write down the set of integers just whole numbers, right? Negative and positive whole numbers including zeros. If they say write the set of integers, right, we will then have to say x, right, and the set will be whole numbers from 2 and 2/3 going up. So that will be 3, 4, 5, and so on, like that, and you'll be done, right? So we don't always get straightforward questions like these, but we get questions where we have ranges of x, right? Not just one number on this side. So for ranges, we'll be getting something that looks like this, for example, right? So for us to get something like this, let's say we were working on maybe x squared minus 8x plus 12 is less than or equal to 0, like that, right? And as I've said earlier, we work through this as if there is an equal sign there, as if it's a quadratic equation, right? So you can use your quadratic formula, minus b plus or minus root of b squared minus 4ac all over 2a, or we can just factorize, right? So factorizing this, we get x minus 6, x minus 2 being less than or equal to 0. And we know that if we have an equal sign here, we then say this bracket is equal to 0 or this is equal to that, right? So at this point, we kind of like ignore this sign, right? So we then say x minus 6 equal to 0 or x minus 2 equal to 0, right? So we solve these separately like this. So this will be your x equals 6 or x equals 2, like that. Now with two answers, like this, or two solutions, we still have to come up with a region like what we have here. This is a region, right? So how do we do that? We need to get the region, right, where this is true, right? And for that, we are going to make a sketch. We're going to be using the graphical method. And so for that, we put our y and our x, right? We label our x's like that, right? So as you can see, we're only dealing with this part of the x-axis, right? So we have x equals 2 and x equals 6, right? Then we go back to our quadratic expression. We look at the coefficient of x squared. Is it positive or negative? It's obvious, right? It's positive. And if it's positive, we know that the graph will be facing upwards, right? Or the curve rather will be facing upwards because it's positive. So this curve is looking like this. No need to get the turning point this time, right? So this is what we have, right? And so whenever we have, so from here we look at this sign that we're given right here. So whenever we have less than or equal to, we are mainly focusing on this region below the x-axis, right? And whenever we're given greater than or equal to, we are looking at the regions above the x-axis, which in this case will be this region and this region, right? So for this particular equation, we have less than or equal to, right? Meaning we're dealing with this, right? And you can see that we have that region from x being equal to 2 to x being equal to 6, right? So we put it this way. 2 is the lowest value that x can take, and the biggest value is 6. Then we write it like this. It's like we're saying from 2 to 6. This is how we're saying we put it, right? So because there is less than or equal to, we can also put less than or equal to there, right? Basically this is what we are saying, right? So if you're given less than, it will be 2 less than x less than 6. And for this one, we have less than or equal to, so we put it like this. But basically what we're saying is we're going from 2 to 6, right? That's why we have this region. But let's say the question was x squared minus 8x plus 12 is greater than 0, like that. So for that now, we would be dealing with, let's just use it like that, we'll be dealing with the regions above the x-axis, and that will be this and this, right? And for us to label these regions, we're still using our 2 and our 6, but this time now, because we're talking about a situation with greater than or equal to, we will be saying x less than 2. Then we put a union, because this is a set, right? It's a set of values giving us that region, right? So union, the other one is x being greater than 6. So if the question had, for example, greater than or equal to, we just put x is less than or equal to 2 union x being greater than or equal to 6, right? But because this had just a greater than, we just write it like this, right? So the question will be saying, and write the set of values for which this is true, right? This. So the set of values will be these, right? Where you are writing your solution to the quadratic equation and the inequality signs involved. And so now that we know how to get the sets of values of x like that, we now need to know how to deal with the nature of roots of a quadratic equation and the discriminant b squared minus 4ac. This is the discriminant that I'm talking about, right? So we have three cases that we excuse me, that we might want to remember. All right, so we know that the graph crosses the x-axis at critical points, which we call solutions, right? So we're saying when the discriminant, this, let's just use d, when the discriminant is equal to 0, like that, we have two equal roots, right? In other words, we have two equal solutions, right? This way we get something like maybe x minus 2 equal to 0, where we get x equals to 2 twice, right? So we have two equal roots when our discriminant is equal to 0, right? And if our discriminant is greater than, let me get rid of that equals, is greater than 0 like this, right? It means we have two real roots that are not equal, right? We have two real roots that are not equal, right? For example, x minus 1, x minus 3. We have 1 and 3. We have two real roots that are not equal when the discriminant is greater than 0, right? And when we have the discriminant being less than 0, it means we have two unequal when we have the discriminant being less than 0, it means we have no roots at all, right? No roots. So if we're given a quadratic expression, then you see that the discriminant b squared minus 4ac is less than 0. It means for that expression we do not have roots. So if we are to sketch something like that, it will be looking like this, maybe, right? Not touching the x-axis at all, right? And that will show us that it doesn't have any roots. And for when the discriminant is equal to 0, where we have two equal roots, the sketch will be looking like this. So it's touching at that point, right? The graph will be touching at that point. And according to our example, let's say this is 2. So this will be x equals 2 twice, right? It's not cutting through the x-axis, but it's touching the x-axis at x equals 2. And for this case, where we have d, or discriminant, being greater than 0, the sketch would look like this, right? We get two different answers, right? So for the second situation, we know that we have two different numbers as our solutions, right? That's why we wrote here we have two real roots that are not equal. So the graph or the curve is definitely crossing the x-axis, right? So now that we know what each one of these imply, let's work on a couple of examples of questions involving the nature of the roots of quadratic equations. So our first example will be, let's say, 5 plus 3x minus x squared is equal to 0, right? And we want to make a conclusion about the nature of the roots, right? And so we use the discriminant, or b squared minus 4ac, like that, right? So now with this, we know from our knowledge of the quadratic formula, b squared minus 4ac over 2a, we know that this is our a, the coefficient of x squared, and this is our b, and this is our c, right? So our b squared in this case will be 3 squared, right? And our a will be minus 1, then our c is 5, right? And so this will come down to 9 plus 20, right? So 9 plus 20 is obviously 29, and we can see that 29 is greater than 0, right? So now from what we've discussed here, if the discriminant is greater than 0, right, we have two roots that are not equal, right? Therefore we can conclude here that for this quadratic equation we have two roots that are not equal, right? All right, so let's move on to another example. This time let me try and get a question that a past paper question rather. So let's work on this one. Says find the value of m for which mx squared plus 10x minus 20 equals to 0 has equal roots. That's our question. Find the value of m for which mx squared plus 10x minus 20 is equal to 0 has equal roots, right? And we know that for us to have equal roots, if we look at this right here, for us to have equal roots, the discriminant has to be equal to 0, right? So we might be asked to work these ones backwards, so they might give us equal roots, so we'll be using this, or we get the discriminant greater than maybe 0, for example, then we conclude by saying this, right? So for this particular question, they said for which that has equal roots. We know for equal roots the discriminant has to be equal to 0, right? So we write for equal roots, right, b squared minus 4ac should be equal to 0, like that, right? Our b, right, is 10, our a is m, and our c is minus 20, like that, right? And from here now we're saying our b squared, that's 10 squared, which will give us 100, minus 4, our a is m, and our c is minus 20, like this. And you know this is equal to 0, right? Because we're looking for the value of m for which this has equal roots, and we know it can only have equal roots if the discriminant is equal to 0. So that's how we came about this. Now this comes down to 100, right, plus 80 m equal to 0, like that. And this will give us 80 m equal to minus 100. And our m will be equal to minus 100 over 80, like that, right? And this will give us m to be minus 5 over 4, right? And that will be the value of m, right? So just be on the lookout. They might give you phrases like these ones where you need to refer back to your understanding of discriminants and the nature of quadratic roots. And right, so from here, the last thing that we need to cover under quadratics for AS level is a concept known as disguised quadratics, right? And for that we get something like ax to the 2m plus bx to the m plus c equals to 0. A, b, and c are just numbers, right? So in other words, this power right here will be double this, right? Let me give you an example. 8x to the 4 minus 4x squared is equal to 0. So just by looking at this, it looks impossible to work out, right? But just remember that equations like these are what we call disguised quadratics, right? And by that I mean we can use our simple quadratics to solve these, right? So we can say, for example, let our x squared be y, right? And by saying this will become 8y squared minus 4y equals 0, right? And I know that most of you are familiar with this. And now with this, we're just factoring out our 4y. Then we get our 2y minus 1 is equal to 0, right? So 4y equals 0, or 2y minus 1 is equal to 0. Get our y equals 0, or y equals a half, like that, right? But now we need to go back to this. Y is standing in for x squared, right? So then you have to say x squared is equal to 0, or x squared is equal to half. And for us to get x values, right, we say we square root both sides. So this will be x is equal to plus or minus root of a half. We can't really do anything about this, right? We can just say x equals to 0. It's a conclusion, right? So this is a simple way of working through questions like this. Another example that you might get is maybe x to the power 2/3 minus x to the power 1/3 minus 2 is equal to 0, right? You can see that this is double this, so you can just go ahead and say let y be x to the third, right? Then you say your y squared minus y minus 2 equals 0. Then you solve this equation, right? Let's say you get your y to be 2 or y equals minus 6, for example, right? You then refer back to this and say it's my x to the third that is equal to 2, or my x to the third that is equal to minus 6. So to get rid of this, you put everything to the power 3, right? So this would be x equal to 8, or x equal to minus 6 to the power 3, right? This should give us a very big value, but that's how you work through that, right? And this brings us to the end of this video. So if you found any of this useful in any way, please do give this video a thumbs up and do consider subscribing to my channel for more videos.